Build BST from scratch. In this lecture, we are going to see, given a set of elements or an array of elements, how do you create a BST from it, a binary search tree from it. So let us see. If you are given a set of elements, what do? You take those elements one by one and you want to insert into a binary search tree. So initially, you don't have anything. What do? You create a root. Whatever is your first element, you'll create a node with it. You'll call that node as a root. After this, what you have to do is whatever we learned in the last two lectures. That was how to insert an element into a binary search tree. That process you have to follow for all the remaining elements so as to build a binary search tree. So let us just understand this. Initially, whatever be your first element, that will be your root. So you created a root. After that, with the second element, what will you do? Whatever be the value of second element, you'll see whether it is less than the root or greater than the root. If it is less than, you will insert it in the left side of root. If it is greater than, you will do in the right side of root. Similarly, you will keep picking each element. You will recursively do this process. That is, if it is greater than root, you will come here. If it is again greater than this, you will insert as the right child. If it is less than this, you will insert as the left child. So you will always insert whenever you see a node on which there is no child and you can insert. So if it is already a right child is there, but you want to insert on left child, that you can do. Or if it is a leaf, then also you can insert. What we'll do, we'll take some numbers, we'll take a set of elements and then try to understand. So if your elements are 74, 21, 50, then 63, 32, 15, 80. If this is the order of elements, see, the order of elements really matter here, because if you have a set of elements in one particular order, there is only one BST structure possible. Only one binary search tree structure is possible if you have a set of elements. So in this same order, the same set of elements in a different order may or may not create a different binary search tree structure. But with this same set of elements, with the same order, you will have only one binary search tree structure. Let us understand this. First element is 74. So what will you do? You'll create a root with value 74. Second element is 21. You'll check whether 21 is smaller than 74 or is it larger than 74. 21 is smaller, so you will add as the left child. What about the next one? 50 is smaller than 74, so you will come to the left side of 74. Again, you will check with 21. 50 is larger than 21, which means you have to add 50 to the right of 21. Which is the next element? It is 63. 63 is again smaller than 74. It is larger than 21, so you will come to the right side of 21. It is again larger than 50, so you have to attach as the right child of 50. 63 will come here. Next element is 32. If I try to add 32, 32 is also smaller than 74. It is larger than 21. Then it is smaller than 50. So it will go as left child of 50. So 32 will come here. Next is 15. 15 is smaller than 74. I'll then compare with 21. 15 is smaller than 21 as well. So 15 will come as left child of 21. Next is 80. 74. I'll compare 80 with 80 is larger than 74. What will I do? I'll add as right child of 80. So this is the final BST structure, the binary search tree structure. One thing I'll do is, let us just try to alter the order and see how a different BST is formed. I just want you to see that when I alter this order, the whole binary search tree structure that will be formed will be different. So let this be here. I'm going to just alter the order. What I'll do is I'll put 50 first. Then let us say 21, 74. I'm using the same numbers here as it was there, but I'm just altering the order. Okay, 32, 15, 63, what is remaining? 80. So if I'm trying to build the BST with the same numbers but in different order, with this order, let us see how the structure changes. Okay, so 50 is the root, then I have 21 smaller than 50, 74 is larger than 50. What about 32? 32 is smaller than 50 but larger than 21. So 32 will come here. What about 15? 15 is smaller than 50, smaller than 21. So 15 will come here. What about 63? 63 is larger than 50 but smaller than 74. What about 80? 80 is larger than 50, larger than 74. So 80 will come here. So this is the binary search tree that I formed with the same elements as this but in a different order. So this is where I want you to understand that when I fluctuate the order, the whole structure of binary search tree will change. It's not that it will always change. It may change, it may not change. It actually depends on what exactly is the order. So what we do next time is, let us just write the pseudocode, but there is nothing to write in the pseudocode much because we are using the same insert algorithm that we learned in the last two lectures. See, if binary search tree concepts or something are not clear for you, please watch the previous lectures where we explained it in detail. So here we are just trying to build the binary search tree and show you how to build. Okay, so we'll just write the pseudocode for building. Let us say build binary search tree BST from a given array. Consider this. What should you do? Initially, you want to build the root. So let us say root is equal to, what should be your root? Root should be a new node created from the first element of array. So I'm writing as create node of array. So this function should simply create one single node, put the value of array of 0. Whatever be the value of first element of array, you should put it into this node. So that we'll consider as the root. After this, what should you do? You should go to each element of the array and do BST insertion. So for I is equal to 1 to length of array minus 1 from second element to the last element. It is 0 indexed. That is why I is equal to 1 is the second element and length of array minus 1, whatever it be, that will be the last element. What is the next thing to do? You have to do the BST insert algorithm. So I'm simply writing BST insert because we wrote the whole pseudocode in last two lectures. Insert of, what should you do? Into the root, you should insert AR of array of I. So this is what you want to do. So once you keep, you insert it in the same order, whatever be the order in the array, in the same order, you will be fetching each element and running BST insert algorithm. So this BST insert algorithm, you can refer to the last two lectures where we explained it. So with the BST insert algorithm, when it is run through all the elements, what will happen? You will have complete BST build. So this is the pseudocode for building BST from scratch.